Hello guys, so today we're doing question 162, which is find peak element. It's a medium question, and the question is, a peak element is an element that is strictly greater than its neighbors. Given a zero-indexed array, integer array, nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums minus 1 and nums n is equal to minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in O log n time. Input nums is equal to, for example, one input nums is equal to 1, 2, 3, 1. The output is 2. 3 is the peak element, and your function should return the index number 2. Example 2, input nums is 1, 2, 1, 3, 5, 6, 4. Output 5, your function can return either index number 1 where the peak element is 2, or index number 5 where the peak element is 6. So you see here, 6 is bigger than 5 and bigger than 4, so it's bigger than the elements surrounding it. 3 is bigger than 2, bigger than 1, bigger than elements around it. So it has to be inside. It can't be the last digit because the outside the array is bigger. It can't be the first digit. So the inside the array, because the other outside of the array is also bigger, and the surrounding elements have to be smaller. So the way we do this is, because it has to be an O log n, we do it through binary search, and then we check that the number is in bounds, and then we check the surrounding digits to make sure that it is the peak element. So let me show you on the whiteboard. Okay, so let's say, what was the array? Well, let's say we have an array of, let's say 1, 2, 3, 1. So we can tell right now the peak element is 3, as it's surrounded by small elements. So the way we do binary search is we get a start value, which is 0. So start is equal to 0, and end is equal to the length of the array minus 1. So it will be 3. Then the mid value, we just add the 2 and divide it by 2 and floor it. So pretty much round it down. So let's say the mid is 0 plus 3 is 3, divided by 2 is 1.5, so round it, it's 1. So now we're at index 1 of 0, which is 2. So we check, is index of 2 of 1, so bigger than 0, so is it in bounds? Yes. Now, because it's in bounds, we know that there's an element before it, because it's bigger than 0, there's an index of 0. So is index of 0 bigger? So is 1 bigger than 2? It is not. So then we check of the next array. We check if that is in bounds. So is 1 smaller than end? Yes, it is. So we check, is the element above it, 3, is it bigger than 2? So is 3? Yes, it is. So then we set the start as the current index, so the mid plus 1, mid plus 1. So now the mid is 2. So let's erase all this, because we know that 2 can't be the peak element, as the one on the right is bigger. So we go to the next half. So 2, 3. So now mid is 2. Now we're at 2 again. So, and this end start, sorry, not 2. Start is 2. We set the start as 2, and then 2 plus 3 is 5. 5 divided by 2 is 2.5. So we are at 2 anyway, because we round 2.5 down to 2. So now we're at 3. Now we check, is 3 bigger than 0? It is. Then we check the element before 3. So index of 1, which is 2. Is 3 bigger than 2? Yes, it is. Then we check the other side. Is 3 smaller than nums.length, which is, so we check the index, is 2 bigger than smaller than nums.length, which is 3. Yes, so that's true. Then we check, is the current value, is 3 bigger than 1? Yes, it is. So we know that it's bigger than the value on the left, we know it's bigger than the value on the right, and we both know that it's inbound. So since it's bigger than both values, we know it's a peak element, and we return 3. Now let me show you how to do it in code. So first, we create the start value. So let's start is equal to 0. Then we get the end value. So let end is equal to nums.length minus 1. Now we have to iterate while the start is smaller than or equal to the end. Then we get a mid value. So let mid is equal to math.floor. So it's not decimal, we just round it down. Then we do start plus end divided by 2. Now we check if mid is bigger than 0 and nums mid, so we check the previous value, is bigger than mid, then we know this is not a peak element, so we set the end as mid minus 1, because we can remove the element. We search the first half of the array because we know the biggest one is the biggest element so far is on the left. Now, if mid is smaller than nums.length minus 1 and nums mid plus 1 is bigger than mid, so we know again the current number is not a peak element, then we set the start as mid plus 1. We check the next digit, so the next half. Otherwise, let's do else if here. Otherwise, we know that it's a peak element because both numbers are not bigger, so they're smaller. Otherwise, if it is so, we return the mid, which is the index of the current number. Let's run. See it passes. Let's submit. Okay, that's the wrong answer. Expected. Okay, I see the error. Pretty much here we're comparing the index value, not the number. So here we put nums mid, so we compare the number, make sure that it's bigger than the number, not the index value. Nums mid. Now let's run. Or let's submit. We already know the first two cases passed. Anyway, as you can see, it's the first time complexity of O log n, as we're doing binary search, which pretty much searches in halves each time, and the space complexity of O1. Thanks for watching.